Hello students, welcome to the channel. In today's session we are going to look at a unique problem in isometric where this slant surface has an inbuilt circular portion given. So you can see the problem on your screen. The methodology is quite simple, but for this particular circle we'll have to go by a systematic approach. So let us resume. So like you can see the problem, I have tried to copy it in the paint tool. The same problem we are going to look at. I have divided the problem into multiple layers. So this approach is very useful for those who are not that good in imagination or creativity. So for that what I have done is where the section is changing, you can see this length and there is change in length. So between that I have marked first layer, that's A. Between the next change in length I have marked it B, and the last one I have marked C. From this length it has reduced to this one. Now the same layers we can see the height being same in front view and side view. Now they have specifically mentioned in this problem that it is left hand side view, and this is front view of course. So we know that between front view and any side view the height remains the same, and hence the height of section A or layer A and here will remain the same, and that's why both these layers belong to A. In this case both of them belong to B and both of them belong to C. Of course we can match the projection lines also to see that carefully. It is already given. And the last one. What does it mean? That A section here we will get the height and the length, and here we will get height and the width. For B section we will get length, height, and here we will get the width and height. Same thing about C. If you see about A and B, the cross section here remains the same, but for C the cross section has altered. That means for the C section the bottommost width is this much and the topmost width is this much. That's a reducing area. So we can see this particular line, which is nothing but a plane, which will be represented in front view by this particular plane. So this particular plane and this line are same. So this plane starts from this point and it is inclined not only in front view but also in side view. That means from this point it is going inside. From this point also it is going inside. So it's a reducing basically. All the dimensions are given, but for keeping it aside for better understanding I have not shown them here. So let us try to draw the schematic of this. We'll start it from the bottommost layer. It's better to start with that. Of course when it's a problem of front view and side view, we know that the origins are always shown at the extreme ends. So these are the origins I have. I'll mark it O dash for front view and O double dash for side view. Let me complete the corner. So this is how your corner starts. So basically A starts from certain distance from the origin, and we can see in front view A is in side view the A is represented by complete rectangle. We can see it has gone inside. That means it's an inclined plane which is shown here as a rectangle. So basically A will start from its end something like this. Now it has gone inside slightly, so there is chance that it will go like this, and here also it will go like this. We are right now not bothered about the dimensions. You can see there is no line present here, so there is no line here as well. and then we can see at this level, which is this as of now for us, there is this line, which means that thing has gone inside as a line. There is a possibility that it has gone inside as a line equal to this complete length. So at the end also we are supposed to get a similar projection of A, and we will get a continued rectangle. That means this rectangle is shown by this. So this is the layer A. The same thing will be present on that side, but since we are looking at the solid like this, there are hardly any chances that we will be able to see a similar section on that side. So let us move ahead to B. Now in case of B, you can see the lines are protruding out up to the end. So possibly the lines will come out, they will be parallel with this, and here also they will come out parallel with this. Then they are going up. So it's a systematic rectangle that we are able to see, and hence they are going up like this. This continue and complete it. So this is how the rectangle B is seen. So we are covered with B and A, but you can see in side view the width of B is also specified. So let us specify the width of B. And this width is parallel, of course, to the main width. Now since we have drawn this, whatever part of A which we had drawn will not be seen, and hence we have to erase it, even this small part. So the part of A will be visible only up to this, and this part won't be seen because that is hiding behind the solid. That's why I have erased it. Fine, let's move ahead. Now there comes the part C. So let us look at this. The width is reduced up to this. It has started from this point, so definitely the part C will start from this point. The width you can see in front view is only this much, and it has gone up to the end. This vertical surface says that there is a continuous plane present at the end. See, we are looking from this side for the front view. Listen to my words very carefully. From this side we are looking for front view, and from this side we are looking for the side view. So when you are looking from this side, you will get left hand side view. When we are looking from this side, we will be getting front view. So when we are looking from this side, at the end we will get a particular line. That means it's a plane. I hope you understand that in isometric, when it is a line, it actually represents a plane. When it's a point, it represents a line. For example, this particular point represents this complete line. Similarly, this particular plane represents the continuous plane which is present. So at the end there will be a plane, but is it a vertical one? No, you can see it is going inside. So up to this point, yes, it is vertical, and then it is going inside. Now let me mark this particular length somewhere here. That is the desired length we have. Now this length will be connected with this point. So this particular line represents this thing. A similar line will be present on that side, but we'll draw it afterwards. Now you can see this particular line is a plane which is of this width. So from this point the line emerge. From this point also parallel lines will emerge, because we can see point 1, 2, 3 and 4 all are the lines of the equal length. You can see they are of equal length. So that's just how I'll draw all those lengths. Since we can see them as lines from here, they are the complete plane, so let us complete them. That is how they are completed. Let me remove extra part. Fine. Now we have reached a certain distance. We can see now from the point where they are aimed, there emerged the plane which comes down and get connected with this point where the plane B has ended. So we will connect this point with B. We'll connect even this point with B. They are mutually opposite. And thereafter there are no planes emerging as lines from these 2 points. So there will be no line of this kind from this thing. So it's not needed. But somehow there are the circles which are present here, which we are going to learn in today's session. Now it is quite understood that the circle that we can see from front is present on this particular inclined surface, and in reality it's no more a circle, it becomes an ellipse. But at the back end, which is a straight surface, we can see that as a circle of the equal radius. So let me try to draw the schematic of it. We are supposed to get an ellipse, of course this semi-ellipse of this kind, and a circle part of this kind at the end. So this is how the problem will get completed. So this is how the view we will be getting. So let us proceed and draw it, and at the end we will learn how to draw this kind of circles on the inclined surfaces. So let us begin. So using CAD tool I am doing this, but you are expected to do this using your manual methods, of course. Let me quickly make the master box based on the given dimensions. So based on the given dimensions, I have prepared the master box, which is of 60, 60 and 90 in the lengths, respective lengths. This is isometric view already we have started with. Let's start drawing the view based on our perception of the problem. So let us start with this base, and to draw this base let us start with the center point. The base we can see is of 70 millimeter. So I will start with the center point. So this is merely for the marking purpose, and since it is center line, I will draw it as a center line for better understanding. Now we know that on either side it should be 35 because the total length is 70. So I will take a length equal to 35 on either sides. Now there is no angle specified here, so we can't go by angle method, and of course in isometric it is not possible to draw the inclined edges using angles because it is also the isometric view. So let us go by this 40 millimeter distance between these 2 points. So from center both the points are at a distance of 20 millimeter, but the height between the 70 and 40 millimeter distance is 10. So we need to copy this line above, or in short we need to draw a parallel line to this at a distance of 10. Now we have got the reference of this point. Now from this point we have to take distance equal to 20. Similarly on this side we have taken distance equal to 20. Now these are being construction lines because there is no line present here, and will not erase any of the construction line. I'll make it very light in nature, and then I will join these points respectively with the endpoints of 70 millimeter of this kind. Now since these are the final views, I will make them dark. Let me apply the darker thickness of the, so that is how it becomes darker. Now we know that as per our perception the line should go inside, but of course a very small distance. Instead we will work on these lines which are coming out and then going up by a distance equal to 10. We can see in problem is the distance equal to 10. So let us move ahead. So from here a line will come out. The distance is merely 25. You can see it easily. And here also on that side the distance is 25. You can go through the calculation using the geometry, and from there it is going up by 10 millimeter. So we will draw a 10 millimeter line. Same thing, we will draw 10 millimeter line here, and thereafter we can see it clearly that these two lines now are going inside for the complete width available, which is 60, and then it frames a rectangle. So from there we will draw two lines of 60 millimeter each from respective points, and then we'll join those two lines, 2 points, which makes the rectangle. So let me make them dark again. So that is how the things are done. For the further thing, we need to identify these 2 points, and then we can connect the lines like this. So the identification is quite simple. We can see that from the end point it is at a distance of 10, and here also from end point it is at a distance 10. So let us draw two lines specifying that distance equal to 10 here as well as here. Now of course these are going to be construction lines, but before we make them construction, let us draw the lines from this point to this, and of course there will be another line, but which we are right now not interested in drawing, so we'll see it afterwards. From there we can see it's coming out by certain distance, and that certain distance here given is 20 millimeter. So let us draw that line of 20 millimeter from here as well. This is a line of 20 millimeter. We need to show them as the construction lines. We can see at this level they generate a rectangle here and here. The length of rectangle we can see this much, which they have specified is 10 millimeter on both sides. So let us apply that 10 millimeter distance and prepare the rectangle. This is 10 millimeter, going again inside by 20, coming back again by 10. A similar rectangle on this side of 10, 20 and 10 will be prepared. We know that as per our perception, this particular end will be connected here and this end will be connected there. So let us do it quickly. I am going to draw the lines from this point to this and from this point to this, which completes my given straight views. So let me make the dark things. After that let us proceed for the method to draw this kind of circles on inclined plane. Let's call them isocircles. Now they have already divided this into number of points. Of course we will be dividing in the same manner. Now one thing is important here, the radius of the circle and the center point of the circle. So we can see the center point of the circle is the topmost middle point of this front view. So let us proceed in the same manner. So this is the probable point of the center point or circle center point, which is located in the middle of the front view. So using this point we will draw a projection line which will go inside, and we will intersect the line in this manner so that the intersection point is the center point or the origin point of the circle. For our understanding, let us show them as the center lines which we have obtained. Now using this reference, this line, now we are basically shifting all the points of a circle in 2D to 3D. See the method? This point, let us say, is continued in this manner, and now we'll convert our approach to 2D. So this is the flow, and from this point I will draw a random line at a certain distance From that point I will draw a circle of given the radius. We can see the radius is 25. Now this circle I will divide into n number of points. Will take I will divide this circle into some 6 points like they have shown. So let me quickly divide it. So this is how I have divided the circle into n number of points. You can see 6 number of segments I have divided, so that I will obtain those points which are specified in the diagram itself. We will get 1, 2, 3, 4, 5, 6 and 7 points. Similar number of points will obtain here, 1, 2, 3, 4, 5, 6 and 7. Now let me apply the nomenclature for understanding. So that is how I have highlighted the points for understanding, and I have given nomenclature as well. Now we have gone in this manner. Let me quickly repeat the logic. From this point we have shifted in this manner. Now in opposite manner we will shift back. You can see point E and A lie on the same horizontal line, same for D and B and same for C. So in short we are going to take 3 more projections in this manner up to this line, to this, and the last one like this. Now these all are being projection lines. We will reverse them back on this axis like this. Now the next step is to draw this particular line which is missing in our diagram. We can see there is a line which is present. Let us quickly draw it, and let us make it dark. Now there are a few more lines missing, but we'll take care of them afterwards. Now there is another thing, is we have to connect this particular center point with this point. Now the reason behind it is to see the slope. We know that all the lines emerging are connected with the end points on this line. So this point is connected with this is connected with this end point. So logically this center point will be connected with the center point itself. Now this is again a construction line, so let us make it very light. After doing that, now we are supposed to transfer the points on this line. We can see the first point is center point, which if you see are this first and last point, which we have already transferred. Let me highlight for your reference again. Now after that point is highlighted, let us transfer these points on this inclined line. Let us delete extra line part, and that is how they are highlighted by me and transferred. Now one thing is very clear, that from this points the radial distances are emerging. We can see them here. This particular radial distance from center up to this point, and this similar radial. Now there will be the distance horizontal from here. See, the logic behind it is, when we are looking from this side for the front view, we will be able to see this circular point. So this distance of point will remain the same no matter whether the point is present on this inclined surface or it is present on the backmost surface. So that's why we will go by this logic. So let me highlight those distances also for understanding. You can see the distance from the center line of every point. So point B and D both are situated at 13 millimeter as per this diagram. A and E at 22, and the last points are 25. You can go for your own distances using your protractor or rounder. You can use it, and then you can apply the same distances on emerging from this line. So let me do it by understanding. See the way I am doing it. So this is already 25 we know on either sides. So on this point, or the lines emerging from this point in this manner, we are going to apply a distance equal to 22. Similarly, on other side, the distance applied again is 22. In the same manner, the lines emerging from this point, we will apply the distance equal to 13. From this point as well, the distance emerging is 13. Now let me highlight these points for better understanding, and since these are the construction lines, let me make them very light in nature again. So as you can see, I have transferred the points in this manner. So basically these are the points which are transferred. So let me give the nomenclature also for understanding. So these are the required points we obtained. Now we simply have to draw a smooth curve using of course the French curve tool, so that we will get a proper ellipse thing. So let me do it for you. So as you can see, I have drawn a smooth curve passing through these points, which will be ended at these 2 points. Now as this particular is the curve, it is actually a curved surface which is continuously going inside, and at the end, since there is a flat surface present, flat vertical surface present, starting from this point, this inclined curve will be shown there as a circle. So using 4-arc method circle, I am going to draw a circle there, or the semicircle basically. So let me show you how to use the 4-arc method and draw it. Now for 4-arc method, we need to construct a rhombus which is of the given dimensions. Now we know that the given circle is of radius 25, so rhombus prepared will be of the diagonal size, which is of 50 by 50, the center point being located at this point at the last layer. So let me quickly show it, and let me prepare that rhombus. So that is how I have prepared a rhombus. You can see the dimensions also I have given. It's 50 by 50 rhombus, passing the center point passing through this particular center. You can observe it we are using the 4-arc method for the circle, of course. You can see these two are the obtuse angles that we have. So using those 2 angles we are going to proceed. So the procedure is already shown to you in the previous video. Since still I am going to repeat it. I'm going to start a line starting from this point. We'll end it to the center point like this, then again another one at this particular center point, like this. The same thing I'll do with this particular end, the line ending at this point. So this is how I have got a matrix. Now I am going to use a simple circle. So I am going to use a simple circle. I'll keep the pointer here, and I will take a radius equal to this particular line. You can see it. No matter what dimension it is showing here, but you have to take the distance up to this point, and you have to draw an arc. Now this arc we will restrict only up to this particular portion, so extra portion we are going to delete or erase. So this is what the arc we have obtained. The next arc that we can see is this side. Because there is no circle present on this side, we are not going to use this particular center, so of which we need to draw an arc somewhere here, but of which we will be seeing only small portion. So we will start again with a circle. We'll keep our pointer here, and we'll take a distance equal to this length, you can see, and we'll draw that arc, of which only this small part is relevant to us, because thereafter there is a solid, so we can't see the pending arc, and hence we will delete the extra part. Now since this is the major arc which we have to see, we will make it dark in nature, even this small segment. So that is how, using the 4-arc method circle, we have drawn a circle at the end, which completes our problem with a couple of lines pending. So since these are the construction work, I'll not erase it. Instead, I'll show it as construction line, very light in nature. To conclude with, we will draw lines starting from this point. You can see it is overlapping the same line, so I'll extend it only up to this. Let me see whether there is a line which we can see. Yes, we can see another line. We'll draw it up to this point. The extra portion, of course, we've drawn, will erase. So these are the two extra lines which were remaining, and we have completed our diagram. Since they are dark, they have to be dark, we will apply the dark thickness. And at the end, we have to show the origin and of course the angles. So that's the end of our problem, where this 2D as well as 3D things we are supposed to draw. It's quite lengthy problem because of this concept. Otherwise, if we practice some more problems like this, we'll be able to solve them very easily. So in upcoming videos, I'm going to add few more problems like this so that you can have a better practice. Thank you so much for watching. If you have liked this, please subscribe to my channel so that you will not miss any update in future. Please click the bell icon also. Thank you so much.